Okay, our next speaker and the last one in this session is Andrew Gormley from Landcare Research. And Andrew will talk about less traps but still delivering large-scale success, optimizing trapping. Welcome, Andrew.
Thanks very much. And thanks very much for having me here. So I'm, hang on a minute, next back. Pretty easy. Yeah, so I'm from, well, we're now Manaaki Whenua Landcare Research. We've just had a rebranding and a slight name change. So this is around optimising trapping, fewer traps, but still delivering the same levels of success. Work I've done with Bruce Warburton, but also in conjunction with a lot of the Cape to City people, Wendy and Natalie and others. So often trapping networks set up for, they have to be pretty broad, intensive for initial knockdown of predators. But for maintenance control, once they're suppressed to a sort of a low level, we're sort of asking the question, well, how low can we go to keep those numbers low, which requires fewer traps, which hopefully results in a lot of savings. So the previous two speakers, if you're in this room, have actually set this up quite nicely for me, so I don't need to fill in a lot of the details. So we had a bunch of the data from the Potala Project, which consisted of 690 odd traps that were checked every 3 weeks, I thought monthly, but yep, so that's kind of the network around here of the trapping intensity. And you can see this is sort of 12 months of data summarised monthly, where the big dots are, I'll play that again, just showing which traps are actually capturing animals, and it's pretty sparse. So this is after initial knockdown, so this is kind of maintenance control. For our these are our target animals, the mustelids and feral cats. So up the top there, this is the monthly captures of the targets, sort of round about, after an initial sort of a peak, around about 15 animals per month across that whole 690 trap network. The traps do get filled up with other things, so there's a lot of non-targets, capturing more of those than we are of the targets, which is probably understandable. Mice and rats, hedgehogs, possums. So the question being, this is putting that last 12 months of data all together. Still, the smaller dots are things that haven't actually captured anything over that period. So do we need all the traps for any maintenance network? So this is just an example case. So over 30 months of trapping data, 70% of those traps caught nothing. So sort of my role was to build a computer simulation model, if you like, taking that data to simulate the captures of targets and non-target animals, and then reducing that simulated network to see if we would still capture the same number of animals with a reduced network, and sort of pushing it to see how low we could go. So based on the modelling that we've done, which is based on the data that we've obtained, we've got, for the entire trap network, we capture 100% of the animals that we caught. That's kind of our baseline measurement. This isn't to say we capture 100% of the animals out there, it's just saying of the animals we caught, if we reduce that network to 50%, for those target animals, we're still capturing sort of 90–95% of those originally captured animals if we'd had a full network. If the trap network was reduced to 25%, we still might be in the range of 80% of that original capture of animals. We also looked at whether multiple capture traps gave any more efficiencies. So at the moment the traps, they catch one animal and then they're out of action, but what if they were increased to 2 or 3 or 4? That didn't really show any difference, and that's not really surprising given that we're at low levels, so there's not a lot of animals on the ground, so when the trap fills up, there's not really lots of animals around it to interact with that trap. For the non-targets, it was a little bit of a different story, so these were our mice and rats, hedgehogs and possums. There were quite large reductions when you reduced the trap network, and they were almost matched one for one. So if you reduce the network by 50%, you captured about 50% of those original non-target animals. Same with 25. So why the difference? Well, Pody sort of mentioned this before. It's probably related a lot to the home range size. So we've got stoats, ferrets and cats have much larger home ranges than our non-targets in this case. So even reducing that trap network by 50%, 25%, you've still got traps in there that those animals can interact with. Whereas the non-targets that have a smaller home range, you reduce the network and they might then be living in areas that they're not exposed to trapping at all. So the question is, we know that a lot of the traps didn't capture anything, but hindsight's 2020. How do we know which ones we could have removed before we did anything? That's the hard part, really. There's a little bit of information in there in that in the first 6 months of data, if a trap captured something, it was twice as likely to capture an animal for the remaining part of the study than a trap that did not capture something in the first 6 months. So potentially you could put traps out, monitor the first few months, and then if you removed preferentially the ones that didn't capture anything in those first 6 months, you might still be achieving those same efficiencies. But we wanted to use that model to help guide a trap network design for maintenance control and make a tool that was sort of usable for managers to play these sort of what-if scenarios in terms of checking intervals and the amount that we can reduce the network. So we sort of expanded our model, included multi-species, trapping them all at once. We've got a lot of information from the literature and lots of other studies around how trappable animals are, their home range size, reproductive rates, dispersal rates, carrying capacity, these sorts of things. So I'm a sort of statistician modeler, so I'm comfortable doing this stuff and coding, but no one else really in the world is outside of our group. But that's fine, so we did the coding, built a front end in a package called Shiny, which is deployed on the internet, and this is a screenshot of it. There's a web address there, and it's just free to go and use and play, and so it's kind of, perhaps you could see it as it's a little bit disjunct from what actually happens on the ground, but it does enable you to play those what-if type scenarios and look at relative changes in reducing the trap network and checking intervals. So this is obviously the Cape to City. The red dots are the current or proposed grid network or trap network. The different dots, it simulates the density of animals, and you can change all those parameters. So here it's simulating stoats at 0.01 stoats per habitat hectare or per hectare. You can change the length of time you run the thing for and how many days between those checking intervals. And also including the non-target animals by eliminating traps. So traps fill up with non-targets, they're out of action for the rest of the time, so we can put in a rate for those as well. This is just showing a couple of some of the outputs that we get from it. So it's showing a population size of cats in green, ferrets in blue, and stoats in the yellowy orange. The differences that we get if we check traps every 20 days versus every 100 days. So it appears from here, relative to checking them every 20 days, 100 days still keeps that maintenance control level going. But what if we reduce the trap network to just 25%? If you check them every 100 days and reduce that network, it looks like the populations increase annually. They hit their carrying capacity, so there might be issues with what those values of carrying capacity are, but they can all be altered as well, compared to checking them every 20 days where the traps get cleared and they're ready for trapping again. So we sort of summarise, you can run a whole heap of scenarios and summarise that sort of stuff. And it's sort of suggesting to us that reducing a trap network is a sensible way to go in some respects, depending on the parameters and what you believe is out there, as well as increasing that checking interval time. But if you reduce things too much and you push out the checking interval too far, then compared to the a full intensive network where you might be capturing 86% of the cats, you're only capturing 14%. So, yeah, it enables us to have a look at, well, which way is the best way to go. Is it more efficient to reduce the network or reduce the checking interval? It's important also, and the tool enables this, to simulate for longer time periods. Annual growth rates, breeding periods and these sorts of things can lead to population dynamics that you won't see in a short time period. So the other results were just for 100 days, whereas this is out for 1,000 days. So these spikes are where it's annual population growth, so the increases, population gets knocked down from maintenance control, it spikes up again and so on. But over time it's still heading up, so even though you get this sharp decrease, the long-term dynamics might suggest that the population isn't being maintained. The 100-day checks, these decreases every 100 days are obviously when the traps get cleared and reduced out again. So TrapSim, as we've sort of called it, it's this free sort of online tool to be used and tweaked and other things to be added in. It can be run for multi-years, include multi-species. The next challenge for us is to challenge that model with data, so put in actual trapping data that's been gathered now and seeing how that affects what we've predicted might happen. And as Bruce has mentioned, I mean, we've all have to consider the economic sort of things as well. So reducing a trap network by 50% doesn't necessarily mean you're saving 50% of your travel time, because the distance between traps is further, so you might still have to get around the entire network even though you've cut out a lot of the traps. So there's all those sort of things to consider as well. And for maintenance control, multi-capture devices probably aren't really suitable in that respect, because we're at hopefully low levels of the animals. The caveat around that would be where there's highly clustered nodes of animals and populations, even though the overall density might be quite low. So as with Bruce's talk, we've got a management context slide in here, which Campbell might want to address. Yeah.
So Andrew's actually said an awful lot of it in his talk, but I just wanted to re-emphasise a little bit of context here. So again, if you step forward a few years, or maybe even up to a decade, and you said we had 500,000 hectares under control, a lot of what we're talking about doing is using traps which are stainless steel. So they're long life traps. They're going to last for quite a while. And while you might not save 50% of your total cost of an operation by reducing your trap network down by 10, 20, 30, 40%, what you will do, you'll save something on the labour context, but you will definitely be able to utilise your trap infrastructure over quite a long period of time, and so the traps that you don't use and don't need in one part of your network, you can well apply to roll out as you incrementally increase across regions. So there's a context where if you do your first 50 or 100,000 hectares, after 4 or 5 years, you got to the level of comfort that you can actually take 30, 40, 50% of those traps out without affecting your result for maintenance, then actually that's infrastructure you can deploy as you go across the rest of the area. The other thing too is clearly the less traps you've got on the ground, assuming you're getting your outcomes you're after, and that's a critical point which we need to still work through, then there's a reduced commitment for landowners in terms of what they need to do. And the easier we can make this for people, the more likely, particularly where your programs rely on farmer commitment to continue to drive your maintenance, that you are going to keep that commitment involved. Yeah, so I think, and the other final comment on this, when you start to combine this sort of work here that Andrew's talking about and that Landcare have done around a very small percentage of your traps actually catch a large percentage of your pests, what happens then if you introduce into that, whatever it is, 20 or 30% of the network, wireless tech? And you do that over a period of 3 or 4 years. What you're doing is effectively getting the use of wireless, the understanding that wireless brings into the context, but you're not having to wireless the whole network. So it's those sorts of management refinements over time, and we're very early in the journey, But it's those sorts of things over time which I think will make quite a difference to how we actually deploy regional scale predator control. So hey, just want to make those comments.
Thank you for that. So that's, any questions that are happy to take, and or else we'll be around for the rest of the day to talk about that.
Okay, we've got time for one question, perhaps two if they're quick. I see there's a couple, there are hands up, one in the front and two there in the back.
Thank you. That was a really good talk. And what I'm curious about is when we look at this optimising and this reduction of traps, as Campbell said, it's about repositioning that resource in the landscape so that you can push your control effort out further and cover more landscape with the resource that you're running. But I'm interested in when you say, with striking the balance with the percentage of traps that have caught something, what your spacing starts to become when you're deploying your network, when you're reducing your percent traps on the ground through density. With some of the figures you're saying, is it a percent, is it an animal per 0.1 hectare, is it a trap? What's the trap density when you're starting to optimise?
Yeah, I mean, you sort of have to, I mean, it was sort of highlighted, I think, between the change and the reduction between the targets and non-targets. So those non-target species with small home ranges, you have to consider that if the trap network is too wide compared to the animal's home range, then you're going to not expose every animal to a trap, and you're going to get bursts of population increase. So you definitely have to consider the biology of the species when you set the trap network. There's not a one recipe fits all. For these target species, the home ranges are kind of different, but they're in the similar ballpark, sort of compared to the non-targets. So if the target was rats or hedgehogs, then you'd have to have a really finely intensive network, yeah. And as I said, the challenge is knowing which traps you can remove if that's not the case, because yeah, we can look at the data over time and say, well, if only we'd not put those 70% out, but we don't know that, you know. So, but if we can base that also on perhaps habitat features as well, then that might be able to sort of help with those sort of efficiencies as well, yeah.
One more question in the back. Yes, thank you.
Kia ora. I picked up from this presentation and also the previous one that there's less advocacy for self-resetting traps, and I'm curious about whether that's coming from a lack of confidence in the technology and the lifespan, because obviously 20 years sounds pretty good for a bit of tech, or is it more about the reduced engagement aspect and the necessity to keep those landowners engaged in the technology? And yeah, I'm curious about your thoughts on that.
From my perspective, from the sort of the data side of it, it's just more in this context where we're talking about low density maintenance control. Having traps that can capture multiple animals, they're kind of potentially redundant because there's just not enough animals out there to capture. So, from those animated slide, we were getting, only one animal among a line of traps caught every month. So they were pretty sparse captures, and so having the ability to capture 3, 4, 10, whatever, is it's probably redundant. But it also depends on, I guess, if the ability of the lure was long, and I don't really know much about that sort of stuff, then perhaps they're back in the picture again for that maintenance control. Yeah.